Hey everybody, I am back with another video lesson. Today is day 2, transformations of exponential functions. Hopefully day 1 was alright. If you have any feedback or suggestions about the first video lesson or things I can improve going forward, please let me know. I greatly appreciate all the feedback I got so far. So if you have anything you want to tell me, please tell me. It really helps. Alright, so let's try this warm-up. If you want to take a minute or two, pause the video and give it a shot. Alright, so we are trying to find the equation of the exponential function shown over here. This question was pretty similar to the last question on the first assignment, which gave a couple of people a little bit of trouble. So let's take a look at it. I'm giving two points, and I know it's an exponential function. So if I know it's an exponential function, I can write it in the form y equals a times b to the x power. Right? And the parentheses here aren't really necessary. It just, well, when we write it like this, people tend to multiply a and b together, which you can't, right? Follow order of operations. So I just like putting in the parentheses. Makes it a little clearer. And if we have 2 points, we can plug in both points and we can get a system of equations. That is one way of doing it. The other way is to solve it like you would a sequence or a geometric sequence. So I'll plug in the 2 points first. We have negative 2 comma 128. So y is 128 and our x value is negative 2. Right, our other equation is going to come from plugging in the point 2 comma a half. So when y is a half, or I should say when x is 2, y is a half. So solving this as a system, we're actually going to divide the two equations. 128 divided by a half is 256. A divided by a is 1. And b to the negative second divided by b squared. Remember to subtract exponents, that is b to the negative fourth. Right? Yeah, that looks good. And so 256 is equal to, that negative exponent, I can make it 1 over b to the 4th power. If I take the 4th root of 256, I believe that is 4, and that's equal to 1 over b. And solving for b here, b is 1/4. Right, you can multiply both sides by b and divide by 4. We get b as a quarter. All right, so once we have it like this, well, we can plug in and then find the a value. So I'm going to plug into this equation. 1/2 equals a times b squared. 1/2 equals a times a quarter squared. So 1/2 equals a times a 16th. And then multiplying both sides by 16, it looks like a is equal to 8. So putting together that a value, 8 and our base, a quarter, we have our equation. Y equals 8 times 1/4 to the x power. So apparently that coordinate there is 0, 8. Right? That a value, that's the y-intercept. So definitely not drawn to scale, but that should be 0, 8. And just like with geometric sequences, you don't necessarily have to use this point to write the equation. Right? That's like using the zeroth term for a geometric rule, an explicit one. We could also use 2 comma a half to write our equation once we know the base. So once we had this, another way to write the equation is y equals, so instead of using 0, 8, if I use the half, it'll be a half times a quarter to the x minus 2 power. Or if I use the point negative 2 comma 128 to write the equation, that would look like y equals 128 times a quarter to the x minus negative 2 or plus 2 power. Right? If that makes you a bit uncomfortable, don't worry too much about it. You can always just find the a value and write the equation like this. Right? This is analogous to using the zero-if term of a geometric sequence to write the rule. Right? This would be like using the second term to write the rule, and this would be like using the negative second term to write the rule. Right? And, oh yeah, I said we could also do this like a geometric sequence. So another way to think about this is to go from the negative second value of x to the 2f value of x. Well, we need to multiply by our base 4 times, or the common ratio if you're thinking of it like a sequence. So to go from 128 to a half, I need to multiply by this b value 4 times b to the 4th. And if you solve that, you should also get b is equal to 1/4. So another way to get the b value, if you don't like setting up this system and dividing the 2, right, think of it like a sequence with terms, and you would get this setup, which also lets you solve for b. All right. Moving on. What are the transformations from f of x equals 2 to the x to each of the following below? Make a table of values and sketch of this function first. All right, so let's make a sketch of f of x equals 2 to the x. If we're writing it like this, y equals a times b to the x, well, the a value here is just 1, right? Our base, what we're multiplying by each time, is 2 to the x power. So because that base is greater than 1, I know it's exponential growth. That a value was 1, so this point is 0, 1. You can also just plug in a 0, of course, to get that value, right? At 1, if I plug it in, I'm going to have 2 to the first, or 2. So I have the point 1, 2, right? It's going to double. At 2, it's going to be at a value of 4, 3, 4. It's going to double again, right? At a value of x equals 3, the function will equal 8. It'll double again, etc. All right, so it's going to look like that, exponential growth. Boom. All right, so now make a table of values. Probably should have done that first, but f of x, right, when x was 0, f of x was 1, 1, 2, 2, 4, 3, 8, and then going the other way, 2 to the negative first power would be a half, 2 to the negative 2 power would be a quarter, etc. We're dividing by 2 each time. Right, so again, we're just going to keep dividing by 2. We're going to have an 1/8, and then a 16th, and then a 32nd. And so as x, again, is approaching negative infinity, this function is getting closer and closer to this horizontal asymptote of y equals 0. All right, so we're going to make this guy our parent function here, and then we're going to do some transformations to it. So knowing what we know about transformations, if g of x is equal to negative f of x, what we're graphing is g of x equals negative 2 to the x power, right? And remember, when we negate a function, what we're doing is we're negating all of the y values. So if I copy this table, copy, paste, right, I'm graphing negative f of x. So if these are the f of x values, well, the negative f of x values would be negative 1/4, negative 1/2, negative 1, negative 2, negative 4, negative 8. Right? All of my f of x values, all of my y values are just negative. And that results in a reflection over the y-axis. Right, same transformation rules as for any other function. Think of y equals x squared and y equals negative x squared. Right, x squared looks like that, negative x squared, the frowny face version, upside down. So same exact thing is happening here. If I wanted to graph g of x is negative 2 to the x power. Oh, and by the way, very important to note that it is written like this. The negative is not part of the base being raised to the x power. It's really more like negative 1 times 2 to the x power. So that is going to look something like that if we graph all the points. And instead of 0, 1, we have 0, negative 1. So that is what the graph of g of x would look like. And let me just adjust it a little. There we go. All right, next, h of x equals f of x plus 2. Right, this plus 2 inside the parentheses, we know we're changing the inputs, the x value. So that's going to be a horizontal shift. And remember, for horizontal shifts, it's usually opposite of what you think. So this is a shift left 2 units. Alright, f of x again was equal to 2 to the x. So f of x plus 2, which is h of x, think of this as function notation. Right, wherever there's an x, now there's going to be an x plus 2. So that'll be 2 to the x plus 2 power. So what would this graph look like? Well, let's make a table of values again. This time it'll be x and f of x plus 2, or h of x. So this time when I plug in 0, what I get is 2 to the 0 plus 2 power. Right, which is 2 squared, which is 4. When I plug in a 1 now, I get 2 to the 1 plus 2 power, or 2 to the third, that's 8. When I plug in a 2, it's 2 to the 4th, that's 16, right? We still have the doubling pattern, just times 2 each time, right? At negative 1, it'd be 2. At negative 2, it'd be 1. At negative 3, it'd be a half, etc. So we got all the same values, just shifted left 2 units. So if I made a sketch of this guy, well, I could actually copy and paste this graph. And if I'm very careful, maybe this will work, maybe it won't, but I can shift it. Whoa, I can shift it 1, 2 units to the left, and there we go. Delete, delete. All right, it actually worked. All right, and our y-intercept is now 0, 4. Right, check out the points on that table. They all match. This would be 1, 8, wherever that is, etc. Right, so transformations, they work exactly like they would for any other functions. Nothing really tricky or new is happening. We're just applying these transformations to a new kind of function. All right, f of x plus 4. Oh, and sorry, by the way, these two previous guys we just graphed, right, they still have horizontal asymptotes at y equals 0. All right, so j of x is f of x plus 4. We know when we're adding on to a function, right, when we're adding on to the y value, in other words, we are doing a vertical shift. So this is a shift up 4 units. And j of x would equal f of x, which was 2 to the x power, and then plus 4 on the outside. So again, if I go to this table, copy, paste, right? What I'm doing to my f of x values is I am adding 4. So instead of negative 2 comma a quarter, it'd be negative 2 comma a quarter plus 4. I'll just use decimals in this case, 4.25, right? This would be 4.5. This would be value of 5, 6, 8, 12, right? We're just adding 4 each time. So a sketch of this function would look like that, right? Our normal y equals 2 to the x, right? If that's 0, 1, except we're going to move it up 4 units. So 1, 2, 3, 4, 5. Our y-intercept goes from 0, 1 to 0, 5. And yeah, this is not a great sketch, of course. I'm just trying to give you an idea. But the interesting thing is if we shift it up 4 units, well, what also gets moved up 4 units? What happened to our horizontal asymptote that was at y equals 0? Right? Doesn't that get moved up 4 units as well? And now we will have a horizontal asymptote at y equals 4. Right? Because remember, this value over here, that was approaching 0 as we got more and more negative. And if we just add 4 onto it, well, now it's going to be approaching y equals 4. Right? Same graph, just shifted up 4 units. So when your function is written like this, not in y equals a times b to the x form, a couple things happen. We can't say that that a value is our y-intercept anymore, right? Because that vertical shift brought our y-intercept up 4 units. It's only when it's written exactly in this form that that a value is the y-intercept. So once we apply these transformations, that rule doesn't apply anymore. Right, and our horizontal asymptote also is not at y equals 0. And lastly, well, k of x is equal to 3 times t to the x power. Yeah, and that is just y equals a times b to the x. Right, that a value is our y-intercept. But also think about this in terms of transformations. When we multiply by 3, right, that's a vertical stretch. We're multiplying all of the y values, right, all of our f of x values, our function, we're multiplying by 3. So that's a stretch of 3. So the graph of y equals 2 to the x, when we do 3 times 2 to the x, right, this point 0, 1, that's going to become 0, 3, because it's a vertical stretch by a factor of 3. This point, which does not look like 1, 2, is going to become 1, 6, so on and so forth. Right? So that's the sketch of this graph. And that is why when you multiply by 3 or by some value a, that value becomes your y-intercept. Because it's just this point 0, 1 getting multiplied by 3, and there we go. So if you want, you can copy this table, right? Multiply all the y values by 3, and then you can get a pretty good sketch of k of x here. All right? So these are all the transformations we've done with other functions, and just like we've done it with trig functions or with quadratics or with square root functions, we're applying the same ideas to exponential functions. So horizontal vertical shifts, reflections over the y-axis, and what do we call this? A vertical stretch factor. All right. So at this point in class, I would have had you talk to a neighbor for a couple minutes and try number 2, matching each of these exponential expressions to its graph. So if you were to graph them, I know you can't graph an expression, but pretend all of these were functions, y equals, and graph them, match them to the graph. All right, so if you want to try, give it a shot. And here we go. All right, so first one, 2 to the x power. So I think that's going to look like B, because we know it's increasing because our base is greater than 1, and the y-intercept would be 0, 1. Is that the only graph that has those two criteria? Yes, it is. So, done with B. All right, 24. That looks like y equals 1 times 1/3 to the x power. So the y-intercept of this one is also 1. And it's going to be decreasing, so that is choice A. All right, 25. That's a vertical shift up 1 unit. So our horizontal asymptote should be at y equals 1. And that one looks like choice G. All right, I want to skip 26 and 27 for now. I'll save those for a little later. They look a little challenging to me. So 28, I'm negating my function. That's going to flip it upside down. So that is going to look like choice F. Right? The positive version looks like that. Reflection over the y-axis. It's going to make it look like that. So that is F. All right, 29. I know my y-intercept here will be 5. So that looks like choice D, and it's still increasing. My base is 2. So what letter was that? That was D. 30. This is going to be a negative decreasing function. So without the negative, right, I know my function looks like that. With the negative, it'll be the reflection over the y-axis. I'm looking for something that looks like this, right? Y-intercept here was 0, 1. Y-intercept here will be 0, -1. So that looks like choice H to me. And 31. This is y equals 2 to the x, but we're shifting it left 1 unit. So if I think about this a little, right, this point 0, 1, everything's going to move left 1 unit. So this point before, which was 1, 2, is going to become 0, 2. And so 31, that's choice C. Right? You can imagine. All right. That's C. All right, which means we're left with 26 and 27. Actually, they're not that bad. I don't know why I skipped these. But 26 is a decreasing exponential function shifted down 1 unit. So our vertical asymptote goes from y equals 0 to y equals -1. And so 26 will match up with letter I, which means the last one must be E. I and E. So 27 is our this function, right? A decreasing multiplying by a third each time, and it's shifted right 1 unit. So this point, which is -1, 3, will become 0, 3 once we shift it over 1 unit to the right. And bam. All right. I'm sorry, guys. These are terrible sketches, but hopefully you get the idea. Let me know if you do not. But that is how I match them up. All right. So next, number 3, determine the key characteristics and transformations, find the domain range, asymptotes, y-intercepts, etc. of each of these functions, and then let's graph. So f of x equals 3 to the x power. We know this is a increasing exponential function. In other words, it's exponential growth, right? Because our b value is greater than 1. 3 is bigger than 1, of course. And if I wanted to make a sketch, might be a good idea to make a table. X f of x, I'm going to start at 0, 1. Multiplying by 3 each time, so 1, 3, 2, 9. Probably can't fit 3, 27, but let's write it anyway. -1, a third, -2, a ninth. And let's see what we can plot. So we got 0, 1, 1, 2, 3, 1, comma 3, 2, comma 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it's a third, then it's a ninth, then it's a 27th, 81th, right? We get really close to the x-axis really quickly, but make sure you never pass the x-axis. That is important. And that is f of x. So let me draw in the asymptote. Y equals 0. What else does it say? Find the domain and range. So the domain, that's going to keep going to the left. That's going to keep going up and also to the right. So our domain for f of x is all real values. Or we can say negative infinity to infinity. Right? Our range is, well, I notice that we're going to start at 0 on the y-axis, and we're going to go up to infinity. But what's new about this function is we can't include the 0, right? Because 0 is not part of the function. The function never reaches 0. So the range is 0 to infinity. Right? Writing it in the other notation, we can say y is greater than 0. Asymptotes, y-intercepts, done. And okay. And now let's graph g of x. When we apply these transformations, we got to apply order of operations. Right? So the first thing we're going to do is flip it upside down. So let me actually break this into parts. Let's do x, and I'm going to graph negative 3 to the x power first. Make sure I have parentheses to indicate that negative 3 is not being raised to the x power. That's not part of the base. Right? And so I think I'm going to copy these values like before, paste them, and when I negate these values, these are all going to be negative. And now I'm going to draw on the +2 part. So right now I flipped it over the y-axis with these coordinates, and now I will move it up 2 units by adding 2 onto all of these values. So that makes our graph become negative 2 and 1/9. Sorry, negative 1/9 plus 2. What is that? I can make that 18/9. So that will be 17/9. Yeah, I think so. Alright, negative 1/3 plus 2. That would be 1 and 2/3, or 5/3. This will be 1. This will be negative 1. This will be negative 7. This will be negative 25. Alright, all I'm doing is just adding here. And what is this as a decimal? Hold on, let me check real quick. Alright, so that is equal to 1.8 repeating. This is equal to 1.6 repeating. 1, negative 7, negative 25. Alright, so let's try graphing this guy now. Well, in fact, I think the easiest way is I'm going to graph the negative version first, and then I'm just going to shift it up 2 units. Right? You can also just plot all those points. They should match up. I will check in a second. 2, 9 will become 2, negative 9. Alright. Change colors. going to go to yellow. Connect the dots. And again, that's the negative version. Now I'm going to shift it up 2 units. I missed the point. So hold up 1, 2. 2 units up. Should look something like that. Let me check my coordinates. Yes, I have 0, 1. I have 1, -1. That is 2, -7 over here. Which means that this is -1, 1.6, -2, 1.8 repeating, etc. Alright, so what did we just graph? We just graphed g of x. Alright, so we're just doing transformations like we said before, or like I said before, on exponential functions. Same rules apply. In this case, because we shifted up 2 units after, our y-intercept is at y equals 2. And also want to just talk about end behavior for g of x here. So for g of x, we can say as x approaches, let's start with negative infinity. So as we're going this way, right, to negative infinity, what are the y values approaching? And we can see we're getting closer and closer to this asymptote here at y equals 2. So as x approaches negative infinity, our function g of x approaches positive 2. And as our function goes to infinity, g of x approaches, so as you go to the right, this function is going down to negative infinity. And lastly, domain and range for g of x. Domain, again, all real values. And range, remember to start with negative infinity, lower value first. So there's an arrow going down, negative infinity, and the upper value for the y's is going to be at that horizontal asymptote, y equals 2. And there we go. That's going to be it for transformations. If you have any questions, let me know. Assignment will be posted due on Monday. Or should I make it due Sunday night? So, haven't decided yet, but I'll let you guys know. I feel like making it due in the morning is, I don't know, giving people the impression they have more time than they actually have. And I don't really want you guys waking up early to do the work, so I think I might make it due Sunday night. But we'll see. Alright guys, have a good one, and I'll see you guys soon.